Hey, Mark Serbu, gun designer, gun nut. Today we've got a video about rails. See these rails? You know what rails are. If you don't know what rails are, you might not want to watch this, but it's not just about rails. It's also about machining a little bit, and a little bit about welding, and a little bit about heat treating. So there's some kind of interesting stuff in there. Hope you like it. If you do, let me know. If you don't like it, let me know. It's not totally obvious at this point, but these suckers are really warped, trust me. The best way you can tell is you put them together, and look at that. That's a lot of warp, and it's not easy to clamp it together. So I've got a big old pair of vice grips here, and this is harder than it looks, because if you don't have the force exactly on the center line, it's gonna do that to you. And we want this thing flat because we got to weld it. What a pain. Gotta be some way to trick it into not knowing that we're trying to do this to it. See, it's resisting because it knows what we're trying to do. Do you believe that? Let me know in the comments, because you're crazy. This might work. Come on. Yeah, this is a lot of force. Come on, stay straight, stay straight. There we go. What's kind of interesting is why these parts warped in the first place, and most machinists should know, and most regular people don't know. If you know, let me know in the comments. All right, I'm going to try. I'm going to go bit by bit, and I'm going to tack together what I know is definitely crunched together, definitely like that, definitely touching. Alright, come on, don't mess with me. Mess with me, boy. Nice thing about welding like this is that as soon as I weld it and it starts to cool, it'll clamp the crap out of it. Okay, here goes. Realize my tungsten looks like crap. Okay. I've reclamped it, got it to submit for a little bit more weld. I don't want to do this too much, because then anything I do now I've got to undo later. These are just temporary tacks, and I'm can you see that? See if you can see that. Just doing it on, God dang it. This thing's such a pain in the butt. Such hate right now. God. See, I might be messing up my part too. It doesn't look like it, but God dang it. Well, let's try something else. Oh. So you guys thought this stuff was easy, didn't you? It's a pain in the butt. Guns just don't throw themselves together for you. Lay out prone before you saying, take me and weld me up. It's a real challenge sometimes. now. Okay. Great, I got it together, but I won't be able to weld this thing right in my face. How about that? Take that, you bastard. All right. Will submit. And this might be one of the last tacks on this side, who knows. It is kind of stitching up nicely. It's bringing it together bit by bit. And as I said before, the nice thing about welding, especially two pieces together with is that a butt weld? Butt weld. As the weld cools, it tends to pull it together big time. So you got a lot of force working for you. So the clamping becomes less and less important. And as I hold it up to the light, the gap is very small now. So I'm just going to keep out. I'm probably going to do one or two more on each side. Will be good. And I know a lot of you are wondering, why the hell am I doing this in the first place? You're probably thinking, what's this about? Well, you wouldn't be laughing. You'd just say, what's this about? And I'd say, sir, would you please step out of the car? But no, we, as in me, I'm going to be putting this in the oven. I'm going to be putting this in the oven along with these little puppies to get carburized. I'm going to put carburizing compound on them and soak them in there at about, I haven't decided, somewhere between 1600 and 1700 degrees for at least an hour, maybe a couple hours, maybe a few hours. And the whole point of that is that this is all low carbon steel and it needs to be high carbon steel, or at least case hardened. So we're going to add the carbon. And in this case, we're doing double duty here because we're not just going to carburize this, but we're going to stress relieve it at the same time. So once I take it out of the oven and cut those tacks, it'll just be nice and straight afterwards because it's been in intimate contact with its partner that is bowed the other way. And so being in this orientation, being absolutely flat and straight now, once it's been at a high temperature, actually you can do this at much lower temperatures, but like I said, we're doing two things at once. We're carburizing and we're stress relieving. So the stress relief is what's going to have it come out nice and flat. You get all that? Got it? Let me know in the comments if you already knew about stress relieving. I'm not talking about, you know, with your friend there. All right, this may be the last tack. We will see. Turns out it needed just one last little bit of persuasion, so here we go. Hard to believe, but the warpage doesn't lie. Yep, I can't see a gap. So finally, 3 tacks on one side and 4 on the other. That's what did it. Now what we've got here is some stainless steel foil, and this is a nice way to cover up stuff that you're heat treating if you don't have a proper ready-made box for it. You know, you can make yourself a stainless steel box with a lid and put all your carburizing compound in there, but this is convenient because all you gotta do is cut it. It cuts with a pair of scissors, which is nice. Always want to wear gloves with this. You want to talk about a paper cut from hell. If you've ever been cut with stainless foil, you will laugh at paper cuts after that. Yeah, it's really bad. Really handy stuff. But it's, I don't know, it's probably 5/1000ths of an inch thick. Actually, you know what? We could actually measure that. Oh geez, no, it's 3/1000ths. It's the thickness of paper. And thickness of paper, the strength of steel. So like I said, the ultimate in paper cut is what you'll get from this. See you do that on Jackass, the next Jackass movie. Instead of just cutting across your mouth with a piece of paper, try this. And the problem with this stuff, though, being so thin, here I am touching it without gloves. The problem with this being so thin is it will get eaten away at some point. So, especially at the higher temperatures. We are going to run this at 1700 degrees, so I'm a little bit worried. But I think I'm going to roll it into a tube. Yeah, what the hell. Been doing this a long time, but still trying new and stupid things, you know? Then we're gonna dump our carburizing compound down there. Now this stuff isn't just pulverized charcoal, though it kind of looks like it. It's got some extra stuff in it. It's made as a carburizing compound. It's good stuff. Make sure you can see that. And it's good stuff. It's also a mess. You know what? I've got a spoon around here somewhere. Let me get that. And just in case you're wondering what I'm using, it's called Will Carbo Pack Carburizing Compound. Man, it's you definitely know that it's not just charcoal when you smell it. It smells a lot like ammonia. Pretty strong, actually, ammonia. Now, the nice thing about this stuff is once you get it inside of a container, along with your stuff, your parts, you don't have to necessarily cover up every square inch of everything, because it carburizes the whole environment in there. It's not just going to be, there's no air is going to be left in there. It's just going to be carburizing crap, if I may be technical. I do want a bunch in there. We'll let this steel know that I mean business. Tired of it not having more than 0.2% carbon. therefore not being able to be heat treated. It's pissing me off. Alright, I'd say that's good enough. It's almost like a burrito, isn't it? Not very fun to bite into, burrito. Alright, I'm sorry, I realized that due to a bad camera angle that you couldn't really see what I was doing there, and I know some of you lack imagination, so here's a reenactment of what I was doing. Now just envision this, even with your lack of imagination, envision this as being the stainless steel tube. So here I was shoving that in there, dropping it in, spooning it in, see, just like that. That's what I was doing that you couldn't see. I know you want to see that. You want to imagine it going. Now obviously there's a tube, it's just going right back in. You can see that. Just kind of like that old gag where they have the faucet with the clear tube underneath. It's actually feeding the faucet water, and it looks like there's a faucet floating in the air with water coming out. There you go. That's what I was doing. Okay, now I realized that due to a bad camera angle yet again, my reenactment was no good. So here's a reenactment of the reenactment. Now here, I was holding this like this. I was simulating putting this in. Here, this is actually it. Here, see that? It's going in like that. Ta-da! Right, enough of that. You know how that goes. And here goes the burrito. Stainless steel burrito with carburizing compound and steel filler. Blah. It's not too bad in there. Man, it gets hot fast though. That's hot. Damn hot. Woo! Damn. All right. I'll get my burrito out of the oven. It's been baking for a few hours. Oh, man. Right, look at that. That is kind of hot. The nice thing about it is that it's still hot inside. The outside's kind of cooled off, but still super freaking hot inside. And we're going to dump this charcoal crap all over the place. So it's going to be a bit messy. There we go. Okay. I can see the ears now. Just gotta grab them up though. Well, I think I waited too long, so that's all right. We'll get them next time. Yeah, that's a mess. But look at this. This is still super, super hot. Oh, and it actually spread a little bit there. That's interesting. All right, well look, since the oven's still hot, we're gonna go ahead and grab those ears and wrap them up and put them back in there. Okay. The ears or the tangs have been cooking in the oven at 1500 degrees. No, 1550 degrees for a little bit here. And I've got them in a little stainless box that I made. I don't know what the hell that is. That's weird. Oh man, that is hot, hot, hot. Oh. Look at that. Look at it glow. It is glowing. I don't mean glowing like a pregnant woman. That's glowing like it gets hot. Now we know it's hot. It's 1550 degrees, right? Ooh, look at that. Ooh. All right. Now the ears are underneath there, so they're still nice and hot. This is what we're looking for. So I'm going to grab them all through their, literally their little ear holes. Oh boy. Come on. Don't be difficult. Keep them hot. Last one. Come on, stay hot. All right, here we go. Into the oil. Into the oil with you. Whoa! That was a really good one, wasn't it? Usually don't get them that crazy hot, and that's fine. Luckily I didn't have my face over there, huh? All right, so there are your ears. And right now they should be so hard that a cat can't scratch them. All right, I like it. I'm just going to leave that hanging out there with the crappy, disgusting used motor oil drip off of them, and in a bit I will clean them off and see how they came out. See, like I was saying there, the rails spread, which is kind of funny. The only reason I can imagine it did that is because when I did that weld and that weld on the other side, maybe it pulled it in so hard that, I don't know, it doesn't really seem right, does it? Now, when I cut these, which I'm going to do here in just a minute, this whole thing should come apart nicely and they'll be nice and straight, except for this end that's flared out. That's just unexpected. I don't get it, but luckily it won't hurt us at all, because as these go in the gun, they're curved inward, so they'll actually grab onto the trunnion harder, as opposed to, it doesn't really matter either way. They get clamped to the trunnion and then they're going to get welded, so won't be an issue at all. Now you notice too, these I've gone along and you can see the shiny edges there. I try to file across there, and a file bites into there no problem, of course, because this just got taken out of the oven and didn't get quenched, and it got to, you know, fairly slowly cool down in the air. Now there are a lot of tool steels called air hardening tool steels, imagine that will harden if they're exposed to just still air. But this is just plain old crappy steel that we've carburized, so we've basically made it, you know, high carbon crappy steel, and it needs a fairly quick cooling curve. Like, you've got to cool this down with oil or water or something, and then it'll harden. But just in air, it'll never harden. You know, I'm looking at this, and one thing that's become apparent is this, when this was machined, it's like you can see it's thicker, like the depth of cut is thicker here than it is here. I bet that's all there was to it. Just, it must have moved during machining, so now we've got a little bit more material here, and that made it want to kind of expand out and give us that gap. I don't know. Nice little mystery. Anybody got any ideas? Let me know in the comments. As long as they're not stupid comments, yeah, I'd like to hear them. Okay. There's that piece of brass again. There we go. And let's see how straight. Pretty damn straight, right? Perfect. So that's what happens when you've got a bend in there and you stress relieve it and it just goes away. Well, basically stress relieving will leave it in whatever shape you leave it in. Like if we'd bowed this thing, like if we'd tacked this to something that was curved, this would have stayed curved once we took it off. But anyway, there you go. Now we got two very nice starts for rails. We're going to get finished machine and then stuck back in. They've already been carburized for a couple of hours, so now they'll go back in and I'll probably just do it for maybe another hour and then quench them. Then they'll be really freaking hard. There you go.